Chapter 9, geometric series. This time we're going to go over finite values. So find the finite sum of the following geometric series. So looking at this, we have 1 over 27, comma, 1 over 9, 1 over 3, 1, 3, and 9. All right, so finite sum. So what we're doing is actually, let's just do this. So these values, so adding those values up, that would be our finite sum. So find the finite value of those there. So of course we have a formula to make this a little bit easier. S sub n is equal to a1 times 1 minus r to the power n, and we're dividing that by 1 minus r. So we have to figure out what the ratio is, or let's see what we have to figure out. S sub n, so finite sum of series. A1, I feel like we're experts at this point of knowing what A1 is. That's the first term. We have R, similar to the previous one, not previous one, but similar to the geometric sequence. R is our common ratio. And lastly, we have N. What do we call N again? The term number. All right, let's see if we have everything that we need so far. So for the finite sum, S sub n, do we know what n is? Actually, technically, we could find that out fairly easy. We have 1, 2, 3, 4, 5, 6 values. So we have n equal to 6. So now everywhere we see an n, we're plugging in 6. Now from here, a1 is our first term. So we have that 1 over 27. 1 minus r, we need our common ratio. So similar to what we've been doing, we look at the second term and either subtract or divide the first term. So here we have 1 over 9, or we could do this math over here. 1 over 9 divided by 1 over 27. I kind of don't like the denominators, so we're going to multiply both top and bottom by 27. Here, those two divide out. Over here, it looks like 9 goes into 27 3 times. So our whole ratio is 3. All right, looks good. Let's try these two now. 1 over 3 divided by 1 over 9. We're multiplying both top and bottom by 9. Those divide out here. 9 divided by 3 is 3. So it looks like we have 3 there too. Let's jump over to these over here. 9 divided by 3, that's a lot easier. So 9 divided by 3 is 3. It looks like with each of these, the common ratio ends up being 3. So minus 3. So far we have a sub n, 1 minus r. We just found out that r is 3. And we're just raising that to the power n. Oh, perfect. We know what n is now. And we're dividing all of that by 1 minus r, which we just found out r is 3. So we have to do a little bit of manipulation here. So we still have that 1 over 27. 1 minus 3 to the power 6. 3 raised to the power 6 gives us 729. And we're dividing all that by this denominator. 1 minus 3 gives us that negative 2. Negative 2. And to make this a little bit easier on us, I want to fix this. So let's multiply both top and bottom by 27. So over here, these two divide out. Down here, we have a negative 54. And in the numerator, we have that 1 minus 279, which would give us a negative, not 279, 729. So that's going to give us a negative 728. So 728, and we're dividing that by 54. And we have a bit of an ugly problem here. Let's simplify this. I thought they would divide out nicely, but they don't. So negative divides out with negative, gives us a positive. So we could kind of divide these negatives out. And it looks like both top and bottom are divisible by 5. Not 5. Both top and bottom are divisible by 9. So top divided by 9 is going to be in... No, I lied. They're not divisible by 5. Are they divisible by 3? Nope. So let's see, 728 over 54. So at the very least, it looks like we could divide out a 2. So dividing out a 2, this would leave us with 6. That's 3, 4, 4. Nope, I lied. That's 3, 6, 4. And dividing this by 2 would be 25, 27. 27. So leaving us with the value 364 over 27. And that's it. So we didn't have to do as crazy of things as a previous video, but still a little crazy. But this ends up being the sum if we were to divide each, or not divide, if we were to add each of those values together to get that geometric series, that's what we would end up with. So that's it. If you happen to have any questions, please feel free to ask. Otherwise, bye.